Today we are looking at 9.3 and we are still continuing on with our graphing, except for this time we're going to graph those rational equations with holes in them. So let's go ahead and start and see what these holes are all about. For number 1, we've got y is equal to x plus 4 all over x squared minus 16. We factor out the bottom. The top hasn't changed. On the bottom we've got x plus 4 and x minus 4. When we factor the bottom, we see that we've got x plus 4's canceling. When everything cancels on top, we've got that placeholder of a 1, and on bottom we've got x minus 4 left. So when we go and we do our vertical asymptote and our horizontal asymptote, we are going to go ahead and look at our new equation of y equals 1 over x minus 4. So for the vertical, hopefully you remember, we are going to set the denominator equal to 0. So x minus 4 equals 0. We have a vertical asymptote at 4. For my horizontal asymptote, we have to look at the degrees. Since our higher degree is on bottom, we have that our horizontal asymptote is going to be at y equals 0. So if you forgot which way it goes, depending on if it's the same degree, high degree, top or bottom, make sure that you are reviewing those notes from the other day. For our x-intercept, we set the numerator equal to 0, which is 1 equals 0. We don't have any variables, so therefore we don't have any x-intercepts. Let's move this down just a little bit more. Our y-intercept, if we want our y-intercept, we plug 0 in for x. So that's 0 minus 4, which is a negative 1/4. So our y-intercept is at 0, comma, a negative 0.25. 0.25 we know is just 1/4. So we draw our vertical asymptote at 4, our dashed line, because it's not part of the actual graph. Our horizontal asymptote at y equals 0. We have no x-intercept, but we do have a y-intercept at 0, negative 0.25. Alright, so we look at the domain. We have a vertical asymptote at 4, so this is going to be all reals except x cannot equal 4. Our range is our values going up and down. That is all real numbers except for y cannot be equal to 0. Now we're going to look at those holes. The holes are going to occur where we had our pieces canceling out in the original function. So since we had x plus 4 cancel on top and bottom, we set that equal to 0. So x plus 4, whatever pieces cancel out, it could be one piece, it could be more than one piece, we get x is equal to a negative 4. We're going to take that x equals negative 4 and plug it into that 1 over x minus 4. So we've got a negative 4 minus 4, which is a negative 1/8. So that hole is going to be located, we had the x coordinate at a negative 4. When we plugged a negative 4 in, we got a y coordinate of a negative 1/8, which is a negative 0.125. Which means if we go over here, we are going to draw an open circle. You have to make sure that you are very, very clear when drawing this that it is open and not a filled-in circle. Our graph does not exist at that point. It's a hole. It's a hole in our graph. So we don't want to forget about that. And if it's a hole and if it doesn't exist there, that means that x can also not be a negative 4 and y cannot be a negative 0.125. Because at that point, we have a glitch in our graph. Speaking of graphs, let's go ahead and get our calculators out and get this in our calculator so we can graph it. Now, when I type in my equation, I can type in either the original or I can type in our converted equation after the holes were canceled out. I always tend to do the original, and this way I can catch any mistakes that I may have made along the way. So if I found a vertical asymptote incorrectly or I canceled something incorrectly, it'll show once I go to my graph. if you do our canceled out version, you're not going to be able to see the hole. So we have that plugged in. We make sure that we're at standard window, zoom 6. And we see our vertical asymptote there at 4, and we see our horizontal asymptote at 0. You probably don't see that hole there. What you have to do is if you zoom in really, really close, so it's at -4, so let's go to our window. Let's go from a -5 to a -3, and let's have our y be the minimum at a -1, maximum at a 1. And all we're doing is zooming in so we can see that hole. And when we graph, if you look really closely, you can see at -4, -1/8, in your calculator, there's like a little megapixel missing. That is the hole. But you have to zoom in super, super, super close in order to see it. And you can see that literally your line jumps over that little spot. Alright, so let's go back to our standard window, zoom 6. And we know that in order to get an accurate portion of our graph, we want 3 points to the left and 3 points to the right. So we go to our table, second graph, and our vertical asymptote's at 4, and we see the error message. So to the left we've got 3, -1, 2, -0.5, and 1, -0.3. Go ahead and plot those, 3, -1, 2, -0.5, -0.3. And we have our x-intercept there. Again, that's going to be drawn approaching the asymptote but not touching. Make sure that you don't draw a line through your hole. If you draw a line through your hole, you're indicating that it is part of the graph. So you want to skip over that hole. We go to the right-hand side, so we want 3 points to the right of 4. And we've got those points are 6.5, 7.3, and 8.25. So we fill those in. Oops, I skipped 5. We don't need the 8. So it's 5.1. So 5.1, 6.5, and 7.3. Again, drawing it so that it approaches each of our asymptotes, but not crossing. Okay, so that's what our holes are. Let's go ahead and do another example. For number 2, we see that we're going to have factoring going on top and on the bottom. On top, we can factor out a 2x. We're left with x plus 4. On the bottom, we can factor that to be x plus 4 and x plus 2. And we happen to have x plus 4's cancel out again. It's not always going to be x plus 4. It can be any quantity that's canceling from the top and bottom. So we're left with 2x over x plus 2. Vertical asymptote, it's always our denominator set equal to 0. So we've got our x plus 2 equal to 0. So we've got our vertical asymptote at x equals a -2. Horizontal asymptotes, we look at our equation. We've got a first degree on top and bottom. So we've got the same degree, which means we're going to divide the coefficient. So it's 2 divided by 1, which is going to be 2. So we've got a horizontal asymptote at y equals 2. Our x-intercept, we set the numerator equal to 0, 2x equals 0, x is equal to 0, so we've got an x-intercept at 0, 0. We plug in 0 for x to find our y-intercept, so we've got 2 times 0, all over 0 plus 2, which is equal to 0. And we know that if we have an x-intercept at 0, 0, we're going to have at least one y-intercept at 0, 0. So let's go ahead and get this set up. Our vertical asymptote at a -2. Our horizontal asymptote at a +2. And we know that we're going to have a point at 0, 0. So our domain, all possible x values, are all reals except x cannot be equal to a -2. Our range, going up and down, our y's can be anything except it can't be a positive 2. So we look at our wholes now. We had x plus 4 cancel out, which means x is equal to a negative 4. We plug that in to our 2x plus x plus 2. So 2 times a negative 4 all over negative 4 plus 2, negative 8 over negative 2 gives us a positive 4. Remember, this is representing your y, and that's representing your x. So your coordinate of your whole is at negative 4, 4. So we go over negative 4, 4, draw your big open circle. I always do this first because if I don't plot it as soon as I find it, I tend to forget to plot my whole. So make sure that you always plot that whole. So that's the point where our graph does not exist, which means our x can also not be a negative 4, and our y can also not be a positive 4. Got to go back to our calculators to see what this graph is going to look like. Clear out our old equation. Again, I'm going to use the original just in case I made a mistake along the way. 2x squared plus 8x. Close out those parentheses, divided by x squared plus 6x plus 8. And we hit our graph. It's already in our standard window. We have our vertical asymptote at a negative 2, so we want 3 points to the left of that. So we go to the table. We go to negative 3. And we've got negative 3, 6. And notice how we had our whole at negative 4, so we got another error message there, which means that we found our whole correctly. Negative 5, 3.3, and negative 6, 3. Plot those points. And again, make sure that you always draw it approaching the asymptote, but not crossing or touching. Now we need to go to the other side for our other 3. So we have that vertical asymptote at negative 2. 3 points to the right there would be at negative 1, negative 2, 0, 0, and 2, 1. Oh, sorry, I skipped 1. 1.7. So negative 1, negative 2, plot our point. We had our x and y-intercept already there, and 1.7. No holes on this side, so we don't have to worry about skip any spots. And there you go. Alright, we only have one more problem on the back page. So why don't you go ahead and turn over. We look at number 3. Our problem does seem a lot more complicated here, but it's not bad. We see on top we're going to factor. GCF is what we always start with. So we pull out that GCF of a 2. And we can go ahead and factor. So two numbers that multiply to 6 and add to 5 are 3 and 2. On the bottom, oh, I'm going to move this down. On the bottom we have 4 pieces. We know that if we're factoring with 4 pieces, we're going to be factoring by grouping. So we're pulling out an x squared, left with x plus 3. Pulling out a negative 4, left with x plus 3. My GCF of x squared minus 4, that's the difference of 2 squares, which is going to leave us with x plus 2 and x minus 2. Again, x squared minus 4 is the difference of 2 squares, which can factor further, and then we've got x plus 3. Now when we look at this setup, we've got x plus 3's canceling, and we've got x plus 2's canceling. So our final equation is 2 over x minus 2, which means we're going to have 2 holes in this problem. Okay, so what I want you to do now is we've done the hard part, we've gotten the equation. I want you to go ahead and try to finish this last one on your own. So go ahead and press pause. Alright, so let's make sure that we have our graph, that you see the same graph on your calculator that we see here. Then we go and we take the equation that we found together. We set the denominator set equal to 0 to get x equals 2. The higher degree is on bottom, therefore we have a horizontal asymptote at y equals 0. Make sure that you have the x equals and the y equals. If not, they're not actually equations of lines. For our x-intercept, we set the numerator set equal to 0, and there is no variable there, so we don't have an x-intercept. For our y-intercept, we plug 0 in for x, and we find that y is negative 1, so we've got a y-intercept at negative 1. When we go to start our domain and range, going left and right, it can be all real numbers except for 2, because we've got a vertical line there. And our range can be anything except for 0, because we've got our horizontal asymptote there. Now we have to go on to those holes. We had canceled out x plus 3's and x plus 2's. So we take that x plus 3, set it equal to 0, giving us an x coordinate of negative 3. We plugged the negative 3 into the new equation that we had found. It's y equals, and we found a y value of a negative 2/5. So either one of these are acceptable, whether you leave it as fractions or decimals. Then we had x plus 2 cancel. So we've got x is a negative 2. We plugged that back in to find that y was a negative 1/2. Again, either one of those two equations could be correct. When we go, or sorry, not equations, coordinates of our holes, we go to our graph, we plot our two holes. Don't forget to plot those holes. You will lose points if you do. We have our vertical asymptote, we have our horizontal asymptote. We go to second graph on our calculator to find the 3 points to the left of the vertical asymptote and 3 points to the right of the vertical asymptote. And hopefully your graph looks the same as mine. Alright, so graphing with holes is exactly what we did earlier, except for anytime something cancels, you're going to have an open spot on your graph. Alright, and that is it for today.